We want to take a look at intrauterine and early life influences on obesity. So the problem is the obesity epidemic in the United States continues to grow. If you look at the data for childhood, which is the earliest recorded data for obesity, we can look at the map from 2003 and see that most of the states are below 15 to 20% at this point, and those who are not generally stay within that 15 to 20% area. However, now in 2011, you can see that most of the states have gone up in the percentage of children who are obese. Today, 1 in 3 children are overweight and over 15% are obese. So why does childhood matter? Well, multiple studies have shown that if the child is overweight by the start of puberty, which is 10 to 13 years old, the chance of being overweight as an adult is 65%. So why does early life particularly matter? Well, certain factors at critical stages, such as fetal development, infants, and young children, are at increased risk of becoming overweight or obese. Two main intrauterine factors that studies have been done on are the mother's weight as well as mothers who smoke. When we're talking about mother's weight, we're talking both about the mother's BMI at conception as well as how much weight she gains during her pregnancy. A high BMI can lead to a large for gestational age infant, which means that the infant weighs more than the average infant at their age. If pregnant women gain too much weight or at too quick of a rate, they can actually have a small for gestational age infant because of the decreased ability for the infant to grow. Once this child is born, the small for gestational age infant has to go through a catch-up phase of growth, which sometimes doesn't decrease and can lead to obesity. When mothers have a large BMI, generally their infant will have an increased adipocyte development as well as an increased risk of type 2 diabetes later in life. This adipocyte development is the starting point for all adipocyte development throughout life. Now, a mother who smokes in pregnancy can also have an effect on a child's weight. Children born to mothers who report smoking were at a 1.52 to 2.22 times higher risk of becoming overweight or obese during childhood. Many of these women who smoke have small for gestational age infants who have to go through the catch-up phase, which may lead to this risk of becoming overweight or obese. Now, BMI. It has been shown that maternal pregravid weight has an early and persistent effect on childhood overweight status, as well as a dynamic effect on the process of overweight developing. Also, there is some evidence linking maternal overweight and obesity, independent of gestational diabetes, to the development of metabolic syndrome, which is obesity, hypertension, dyslipidemia, and glucose intolerance in their offspring. Now, fetal growth or over and under nutrition we hit a little bit on, but we're going to go into a little bit more depth. So the risk of having a small for gestational age full-term baby tends to decrease with the increase of maternal BMI prior to pregnancy, whereas the risk of having a large for gestational age baby increases by approximately 60%. As we talked about before, the small for gestational infants often come when mothers smoke or when they gain weight too quickly during infancy. Also, although pregestational diabetes has a greater effect on the frequency of larger gestational age infants than maternal obesity does, more of the large for gestational age babies are born to obese women than to women with diabetes because maternal obesity is more prevalent than diabetes. So, undernutrition. This is a picture showing an IUGR baby next to a normal baby. So maternal undernutrition during gestation reduces placental and fetal growth in humans. Undernutrition in pregnant women may result from low intake of dietary nutrients owing to either a limited supply of food or severe nausea and vomiting known as hyperemesis gravidarum. Pregnant women may also be at increased risk of undernutrition because of early or closely spaced pregnancies. Low birth weights in preterm deliveries and adolescent pregnancies are more than twice as common as in adult pregnancies, and neonatal mortality in adolescent pregnancies is almost 3 times higher than for adult pregnancies. Further, placental insufficiency results in reduced transfer of nutrients from mother to fetus, thereby leading to fetal undernutrition and IUGR. Finally, due to competition for nutrients, multiple fetuses result from assisted reproductive technologies are often at risk of undernutrition and therefore fetal growth restrictions. Several hormones known to regulate fetal growth and development also may play a central role in intrauterine programming. These include anabolic hormones such as insulin, insulin-like growth factors, or IGR, prolactin, thyroid hormones, as well as catabolic hormones such as glucocorticoids. The association between the birth weight, childhood BMI, and non-insulin dependent diabetes are strongly supported by epidemiological studies from different populations and have been summarized in recent reviews. If we look at fetal growth and metabolism, we know that there is mismatch when a state of nutrition conservation prenatally, such as a low birth weight child, is met with an abundance of or excess of nutrients postnatally to help them grow. This leads to the metabolic process being maladapted and leads to elevated risk of chronic diseases in adulthood, as well as obesity. Small for gestational age fetuses and newborns have significantly decreased plasma leptin levels because of lack of adipose tissues, and studies confirm reduced satiety neurons. Now we want to look at the phase when children are being breastfed. Breastfeeding decreases the risk of high BMI at age 7. An evidence report was conducted on breastfeeding and maternal and infant health outcomes in developed countries, which showed that out of 43 primary studies on infant outcomes, a history of breastfeeding was associated with a reduction in risk of obesity and both types of diabetes. Another evidence base to support the review of breastfeeding policy showed that breastfeeding may reduce the risk of obesity later in life, encouraging infants' emergence capability of self-regulations of intake, reducing problematic feeding behaviors on the part of caregivers, and providing bioactive factors that regulate energy intake and energy expenditure, as well as cellular chemistry. Now, those who are breastfed generally gain weight at a slower rate than those who are formula fed. This may be due to overfeeding, or it could just be something in the breast milk, because it's been found even if those who are breastfed have the same intake calories as those who are not, they still gain at a slower rate. Also, some of the hormones that we were talking about include leptin and ghrelin, which affect satiety and hunger. Breastfeeding can decrease the risk of obesity from 7 to 24%, and part of this is related to the length of breastfeeding. With breastfeeding, we don't know if it's the breastfeeding that causes the decrease in obesity or if it's because of those who breastfeed. It's been found that overweight and obese women are less likely to breastfeed, or they choose to breastfeed for a shorter amount of time. Also, women who are higher educated are more likely to breastfeed. It's been found that breastfeeding promotion and intervention resulted in substantial increases in the duration and exclusivity of breastfeeding, yet it did not reduce the measures of adiposity, increased stature, or reduced plasma level at age 6.5 in the experiment group. Also, infant weight gain is associated with maternal pre-pregnant BMI and with an interaction between the duration of breastfeeding and the timing of complementary food introduction. Some other factors throughout early childhood are family meals. Those who eat meals as a family are generally less likely to be overweight or obese. Also, the division of responsibility. Ellen Sater discusses this, and it means that parents can choose what foods to offer the children and when to feed them, but the child chooses what foods to eat, if they're going to eat, how much they're going to eat, and whether or not they're even going to eat. Many parents who do not follow this force the child to eat 2 or 3 more bites or tell them to join the clean plate club. However, this may teach the child not to understand their satiety cues, but instead to look for visual cues. Another factor is sleeping. It's been found that less than 11 hours of sleep at age 3 it leads to an increase of the risk of being overweight or obese at age 7. There are multiple studies that back up this presentation, and our conclusion is there are multiple factors that can contribute to obesity that are developed during intrauterine growth and early life development.